and then we will start with module number 5. So the name of my module number 5 is the EM wave propagation. So we are going to see the different parameters which are associated with the EM wave propagation. So before we start, first let us revise what we have done in the chapter number 4. So in fourth chapter is dedicated to Maxwell's equations. So let me recall what is the contribution of Maxwell's in the era of the wireless communication. So what are Maxwell's equations and why to study them? So this is Maxwell. And what he has done is he has unified the set of known experimental laws. So Faraday and Ampere's have already done some experiments, and they have from these experiments they have already have some results out of it. And what Maxwell did is he combined all the set of equations, which we call it as the Maxwell's equations. And these equations basically describe the electric and magnetic field arising from the time-varying distributions of charges and currents. So up till now, in the first two chapters, we studied the static electric and magnetic field. So from the fourth chapter, we are studying the electric and magnetic field, which are generating from the time-varying distributions of charges and the currents. So time-varying distributions of charges leads to time-varying electric field, and time-varying distribution of current leads to time-varying magnetic field. So what is another contribution of Maxwell's is the displacement current. He mathematically proved that the EM wave can sustain in the medium which do not have any charges. Okay, so and he also predicted that the velocity of this EM wave is going to be velocity of light. So this particular contribution of Maxwell's is very important, and this leads to the wireless communication. Okay, so he is called the father of the wireless communication because of his contributions, which we call it as a displacement current. So we have studied the new term of Maxwell's equations. Okay, so this new term Maxwell's equations leads to generation of time-varying electric and magnetic field. Then this field can propagate through the space even in the absence of any material. So up till now we have studied that whenever there is a current, there is going to be a magnetic field. But Maxwell's proved that even though there is no current, that means current is due to the charges. Okay, electrons. So even though there are no charges in any medium, still magnetic field can be present, and that is due to the d bar dot term, which we call it as the rate of change of electric field. So rate of change of electric field is the source to give you the magnetic field, which is also time varying. So if you have a changing electric field, the magnetic field, which is also changing, can be created, even though if the material do not have the charges. So that is the contribution of the Maxwell's. So this particular field, which we call it as EM wave, can propagate in the free space. We know that free space does not have any charges. So even though any material which is depleted of any charges, the EM wave can propagate through it, and that particular is the result which is displayed due to the Maxwell's new term. And this particular disturbance is called as electromagnetic wave. So as you can see here, the hand. So as I said in one of the labs yesterday, that the electric field, the magnetic field, and the propagation of wave, they are all in the perpendicular directions. Okay, so as you can see, electric field is varying in the x direction, magnetic field is varying in the y direction, and this as an envelope is traveling along the z directions. Okay, so normally this is the standard that EM wave propagation is considered to be along the z direction. Okay, this is a global way of globally, you refer to any books, the propagation is always along the Z direction. In X direction, the electric field will be noted, and in the Y direction, the magnetic field will be shown. Okay. So what is the implication? As I have already explained, that the magnetic field will be produced in the empty space if there is a changing electric field. Okay, so that is what is the correction in the Ampere's law which Maxwell did, and he added the new term which is d bar dot. So after this, what will happen? This magnetic field will be changing. Okay, so originally there was none. The magnetic field was absent. The magnetic field is produced because of the changing electric field. So this magnetic field will again produce the electric field because of the Faraday's law. This change in electric field again produces the magnetic field. Again, there is a electric field. So this will go on, and this is how the EM wave will propagate. We can see this particular propagation in this small simulation. Getting loaded. So as you can see here, is it understood?
Recording in progress.
What I have here is a disturbance. This is the AC signal. These are the charges which are oscillating. Oscillating means with respect to time it is oscillating. So this is a AC signal which has been produced between these two poles, which is generating a time varying electric field which is varying in the X direction. Once that red color lines are produced, the blue color lines are going to be produced. The blue color lines again produces the red color lines, and this envelope is propagating in the Z direction. So as you can see, the if I okay. Okay, so as you can see, along the electric field is along the x-axis. Horizontally, the B, that is the magnetic field, and this is the Z direction. Okay, so this is how the EM wave propagates along the Z direction. This small animation to show you the same. Let me come to the slide again. Okay. So this EM wave, Maxwell's did all the mathematical combination of all the equations, and he mathematically proved that the existence of EM wave is possible. So later on, these particular equations were investigated by Hertz, and he experimentally could transfer the data or the signal from one end to another, and these waves are also called as the Hertzian waves, because he tried it experimentally for the first time. Okay, so once we understood that EM wave exists in the free space, now we need to study. So students, please understand, we are going to study something which we are not going to see. Okay, जो दिख नहीं रहा है उसके बारे में पढ़ना है, so which is very difficult. So what we have to do first, we have to first explain it with the help of maths. Okay, so first we have to write down the equation of the EM wave, the mathematical equation of EM wave. We can call it as this is mathematical modeling of EM wave. So once we write down the mathematical equation of EM wave, then later on it is possible to imagine how this EM wave is going to be with the help of the maths. So as sir explained last time, maths is very important. In whichever field you go, okay, maths is going to be there. Okay, even in medical field there are maths. So you cannot, students always get scared of maths, but you cannot get rid of maths. Maths is very important. Whoever is working, Shastri sir knows better, whoever is working in the antenna field or any communication field, okay, maths, and if you want to write down technical good papers in general, in suppose IEEE transaction or any good journal, if you want to write down the papers, okay, they always ask for the mathematics behind your results. Okay, without that they are not going to publish your paper. So if you want to go in the research, if you want to publish your paper in a good journal, then it is very important to understand the maths behind it. So now we are going to derive the wave equation in the different mediums. So which are the mediums that we are going to consider? The first is a free space. So in the bracket, I have shown the properties of free space. So this first letter is sigma. So sigma is the conductivity, which is basically due to the charges which are present in the material. So free space do not have any conductivity. So sigma is 0. Epsilon is equal to epsilon 0, because how do you write down epsilon? It is epsilon r into epsilon 0. For free space, the epsilon r is 1, and therefore epsilon becomes epsilon 0. Similarly, mu is mu 0 into mu r. In case of free space, mu r is 1, and therefore mu is equal to mu 0. The second medium is lossless medium. So here also lossless dielectric. So this is also a medium which is not a free space. So it is any other medium which is dielectric, and it is called as lossless dielectric. So it is the perfect dielectrics we are talking about. And here the epsilon r and mu r value is not 1. And obviously it is a perfect dielectric. That means there are no charges, free charges available. And therefore sigma is again 0. Lossy dielectric. So again, this is a dielectric which is absolutely having it is a loss. It is going to have a lots of losses in it. So therefore sigma is very high. Ideal value is infinity. And good dielectrics. So good dielectric is basically a compromise between a lossy dielectric and lossless dielectrics. So it is a dielectric which is good in nature because its sigma is not 0, neither it is very high, which is infinity. So if you have lots of charges, then they are going to absorb the energy from the EM wave, and that is what is the loss which is taking place in the dielectrics. So any medium, if you want EM wave to propagate without any loss, then the charges should be 0, and therefore we say that in the free medium, EM wave travels without any loss because they don't have any charges. So more are the charges, more are the losses which takes place. And that is why this good dielectric is basically the very much practical dielectric, which we can say, which is neither a lossless nor it is too much of lossy. So these are the 4 medium that we are going to solve the problems in. So we will start first with the derivation of EM wave. Again, to derive this EM wave, we have only the Maxwell's equations with us. I'll just explain to you how this derivation is being written. So we will start with Maxwell's first equation. Please remember Maxwell's first and second equation is Gauss law in electrostatics and Gauss law in magnetostatics, which do not have any time variations. Okay, so what is Gauss law in electrostatics? It is divergence of D is equal to rho V, the point form I'm talking about, and divergence of and the second Gauss law in the magnetostatics is divergence of B is equal to 0. These do not have any dot term. So this dot हम लोग बोलते हैं ना minus B bar dot, जो dot bar के ऊपर होता है, vector के ऊपर होता है dot. So ये जो dot है, that dot represents the time variation. So only Maxwell's third and fourth equation has this dot term. And that is why when you derive EM equation, we are going to take help of Maxwell's third and fourth equation. So what I have written here is Maxwell's fourth equation, the third equation, which is minus B bar dot. Okay, so as again, I have to write it down. Okay, so this particular is minus B bar dot. So this dot indicates dabba by dabba t. Okay, so that is what I have written here, which is the Maxwell's third equation. Okay, so let's go ahead. Now I take curl on both the sides. Again, some mathematical operation needs to be done. So if I take curl on both the sides, then I'm going to now remove this dabba by dabba t out of the bracket. So I have curl of E, which is minus dabba by dabba t of curl of B. Okay, now we are going to expand curl of B in the later slides. So let us see. So now we are going to concentrate only on curl of B. Okay, so let us get some expression for curl of B. Okay, so let's write down the expression for curl of B. Okay, and then we will again come back to this particular equation. Okay, so what is curl of B? So as you can see here, we start from curl of H. Okay, we start here with curl of H. What is curl of H? This is fourth equation. Curl of H is going to be D bar dot. Now we are writing this equation in the free space. So we know curl of H is going to be basically JC plus JD. Okay, but we are writing this equation in the free space and therefore JC is 0. So curl of H is going to be only D bar dot. D bar dot is nothing but JD, that is displacement current density. So this D is written as D is equal to epsilon E. Okay, so therefore curl of H is going to be epsilon. यहाँ पे epsilon E आएगा D के जगह. Okay, so this epsilon being constant is taken out of the differentiation sign, and I have here dabba by dabba T of E. In the left hand side, H के जगह लिखा है B upon mu. You know B is going to be mu into H. Okay, but I want equation of curl of B. I have curl of H. Therefore, H is expressed here in terms of B, which is B upon mu. Okay, so therefore, what I have here is curl of B, which is this mu goes on the right hand side. So it is mu epsilon dabba by dabba T of E. So now I'm expanding curl of B. Okay, and then I'll again go back and substitute the curl of B in the previous slide here. Okay, so now we are just expressing what is curl of B. So what is curl of B? It is mu epsilon dabba by dabba T of E bar. Okay, so let's substitute here. What was curl of E? So curl of E, this was our previous equation. यहाँ पे curl of B के जगह मैं ये substitute करने वाले हूँ. Okay, so now I'm going to get my next equation, which is this. Okay, so curl of E is going to be, okay, dabba by dabba T, और इसके जगह अभी मैं ये substitute करने वाली हूँ, which is written here. Okay, so this is the new equation which I have found. Okay, let's go ahead. So the curl of E is going to be, again mu and epsilon are constant, so they are taken out of the differentiation sign. So I have here dabba square by dabba T square of E bar. Okay, so this is the new equation, new expression which I have obtained, which is curl of E is going to be this. Okay. After this, we again now we are going to expand what is curl of E. Okay, so right hand side the expansion or the expression is obtained. Now we will concentrate on the right hand side, the left hand side. Okay, so left hand side में क्या है मेरे पास? I have curl of E. So what is curl of E? So curl of E is going to be, this is according to the mathematical operations of vectors which you have studied. So it is gradient of divergence of E minus del square E. Okay, this is as per the mathematical operation. But what is curl of E is equal to 0. Why it is 0? Because we are talking about a free space. Okay, so curl of E is going to be 0 because what is divergence? Divergence of D is going to be rho V. Okay, rho V कब आएगा? When there are charges. But if this free space there are no charges, so therefore we can say curl of D, the divergence of D is equal to 0. And what is D? D is epsilon E. Okay, so therefore I can say that the divergence of E is going to be 0 in the free space. So therefore curl of E reduces to this becomes 0. ये 0 हो गया. Okay, so curl of, I'm sorry, this becomes 0, not this. Okay, ये 0 है. ये 0 के वजह से ये term आता है. So what is curl of E? It is simply minus del square E. So curl of E, which is my left hand side, is replaced with minus del square E. is equal to this. Okay, so going ahead, my expression becomes del square E is equal to mu epsilon dabba square E by dabba T square. So this is a equation of free space. This is called as wave equation. Okay, so please remember this wave equation. So this wave equation is expressed in terms of electric field, which is time varying, and this is also wave equation. Here we are expressing wave equation in terms of magnetic field, which is time varying. So you can derive any one of it. Okay, and you can use any one of it to in the exam. Either ये derive करो या फिर ये derive करो. Okay, so we may ask you to derive the wave equation in the exam, maybe for 3 to 4 marks. Okay. After this is done, now we are going ahead, and we are going to see what is called as harmonically wave equation for harmonically varying fields. So why we are going into the harmonically varying fields? Because in engineering, the field which we come across are time varying, because we always deal with the AC signals. Okay, so our signals are sinusoidal. So harmonically time fields are the fields which are generated due to sinusoidal variation of the current. Okay, so therefore in engineering we are or in your communication domain, we are going to see the fields which are of this nature, sinusoidal in nature. So fields which are of this nature are called as harmonically time varying fields, and we are going to do it for lossy mediums. That means since there are sine wave, that means there are going to be charges. There is going to be current. Once we know that the current is going to be there, this medium is going to be lossy. Okay, so now the earlier derivation was the wave equation for free space. So अगर free space पे लिखना है मुझे, then once this derivation is done, I have to just write down here mu 0 and epsilon 0. So for free space, mu and epsilon becomes mu 0 and epsilon 0. So you have to just at the end add zeros. Okay, and this is a wave equation in the free space. This is a wave equation in the free space. Okay, so in free space, as you can see, there are no losses which take place. Okay, now we are going to see the wave equation for fields. So these fields are not are going to be not fields which are harmonically time varying fields, but they are in the free space. So there are no losses which takes place. Now we are going to see the wave equation which happens in the lossy medium. Okay, so again I start with the same equation. जैसे last time क्या था, derivation वैसा ही करना है यहाँ पे. Okay, so I start with the third equation of Maxwell's. Okay, so this is what we have done. Curl of E is equal to mu dabba H by dabba T. Okay, so in the earlier case, if you remember, this was 0 because it was free space. So we directly took curl of H is equal to d bar dot, but this is a lossy medium. That means the charges are going to be there. So curl of H is going to be JC, J or JC, whatever, JC and JD both are going to be there. So last time sir had explained the Ohm's law, which is JC is equal to epsilon E, which is equal to sigma E. This is basically your Ohm's law. JC is equal to sigma E. This is Ohm's law. Okay, so JC की जगह मैंने ये लिखा, और JD is d bar dot. D is epsilon E, epsilon being constant, taken out of the differentiation signs. So curl of H becomes sigma E plus epsilon divided by dabba T of E. Okay. Once we understood this, then you actually understand what is EM wave and what is the significance of that. Okay, so now what I'm going to do is curl of E. अभी ये दोनों जगह यहाँ पे curl लिया है मैंने in this equation. So B becomes epsilon mu H. ओके अभी यहाँ पे जो कर्ल ऑफ एच है ना, ये जो एक्सप्रेशन है वो मैं सब्स्टिट्यूट करने वाली हूँ यहाँ पे. दिस एक्सप्रेशन इज सब्स्टिट्यूटेड हियर. ओके एंड दिस वी हैव ऑलरेडी डन इन द लास्ट डेरिवेशन. बेसिकली यहाँ पे दोनों साइड में मैंने कर्ल लिया है, इसका भी कर्ल लिया है और इसका भी कर्ल लिया है, तो यहाँ पे आएगा. एंड कर्ल ऑफ एच इज दिस. तो अभी ये यहाँ पे सब्स्टिट्यूट होगा. ओके सो इफ आई सब्स्टिट्यूट दिस, okay, then I am going to get this. Okay, too much of long expression. So now I think all of you understood why I used to tell you in the lectures the equations are going to be more complex. Okay, so curl of E is going to be mu dabba by dabba T of curl of H. And what is curl of H? Curl of H is this. ये अंदर पूरा multiply किया है, so I get two expressions. In the earlier case, this expression was not there. ये expression नहीं था, only ये expression था. Okay, now this expression is present because of this JC. Because of this JC, this expression is existing. Okay, let's go ahead. Okay, so curl of E is going to be this is 0, so it is going to be minus del square E. ये हमने लास्ट टाइम पढ़ा है. सो माइनस, ये माइनस साइन और ये माइनस साइन और this minus sign and this minus sign is going to be plus. So therefore curl of E, the del square E is going to be this expression. तो ये expression नहीं था last time के expression, last time के wave equation में, only this term was there. Okay, so ये term जो पहली आई है that is due to the JC term. Okay, so del square E is going to be this. Okay, now how I am writing this? Dabba by dabba T E bar is going to be J omega. Okay, so this is because the harmonically time varying fields are written in this way. Okay, that is dabba by dabba T. We always express the time as in terms of frequency. So this is J omega. Omega is the frequency. So now we are converting our domain from time to frequency. So we always work in the frequency domain because in time domain, the equations are very complicated. They are in second order differential equations, which are difficult to handle. Therefore, we always work in the frequency domain. In frequency domain, the equation becomes very easy. Okay, so this also you have experienced that if you have a RLC circuit, और अगर RLC circuit अगर है आपके पास RL circuit, और अगर इसको आप KVL लगाओगे ना, KVL अगर लगाते हो तो due to this inductor you are going to get V is going to be L di by dt. Okay, so whenever you are writing a KVL equation here, ये NT में पढ़ा था आपने. Okay, you get a differential equations. ओके अगर ये फ्रीक्वेंसी डोमेन में लिखते हो तो ये इक्वेशन क्या होता है? इट इज सिंपल, दिस बिकम्स एक्सएल. ओके, सो दिस बिकम्स जे ओमेगा एक्सएल. सो जो डिफरेंशियल इक्वेशन होता है ना, वो सिंपल अल्जेब्रिक इक्वेशन होता है इफ यू वर्क इन द टाइम इन द फ्रीक्वेंसी डोमेन. सो देयरफॉर इन द हार्मोनिकली टाइम वेरिंग फील्ड्स वी ऑलवेज वर्क इन द फ्रीक्वेंसी डोमेन. ओके, सो देयरफॉर यहाँ पे क्या किया है, dabba by dabba T is replaced with J omega. Okay, so अभी यहाँ पे changes करना है मुझे. Okay, so I make these changes and this is my equation. So wherever there was dabba by dabba T is replaced with J omega. Okay, so this becomes J omega. और यहाँ पे square है इसलिए J square omega square आया है. J square is minus 1. So therefore going further, this is my expression. Okay, which is J यहाँ पे कॉमन निकाला है इसलिए माइनस साइन नहीं आ रहा है यहाँ. So this is my final expression for wave. This is also a wave equation, but it is in terms of harmonically time varying fields, and this particular is called as Helmholtz equation. Okay, so for communication, this equation is very important, and this equation we are going to consider later. Okay, in our discussion. So this particular equation is called as Helmholtz equation, wave equation in terms of electric field. Okay, so please remember this Helmholtz equation Okay, so we have done two wave equations in two different mediums. One was lossless medium, and this is the lossy medium. So in lossy medium, and the field is sinusoidal varying fields. So we have expressed now the wave equation. So this was our wave equation. यहाँ पे जो ये gamma hai, this particular you already have understood this is gamma. So this was our right hand side. यहाँ पे gamma square लिया है. So this is your gamma square, which is equal to this. So what is gamma? It is a propagation constant. So this gamma is a propagation constant, basically giving you the understanding of the propagation. EM wave propagate hota hai, so you get some information from this gamma. So what information you get? This is a complex term, and this gamma is always has some real and imaginary term. So this gamma is always alpha plus j beta. Is j beta. So ये propagation constant आपको क्या information देता है? It gives you information about alpha. So what is alpha? Alpha is attenuation, and beta is phase constant. So whenever EM wave propagates in any medium, what is happening to its phase and what is happening to its attenuation? Whether it is getting attenuated or whether uska phase change हो रहा है कि नहीं, that information is obtained using the propagation constant. So this propagation constant is called as gamma, and it is alpha plus j beta. Okay, so now we have obtained the gamma, which is alpha plus j beta. तो अगर इसको आप solve करोगे ना, if you solve this particular expression and if you solve this equation and get it in this form, okay, then you are going to get alpha and beta in this form. This is alpha and beta. So if one knows the frequency of the EM wave and the properties of medium, then one can understand what is how much is the attenuation which is going to happen when EM wave propagates in that medium, and how much is the phase change which is going to happen when it is in that medium. So this is the, again ये formula याद रखना है आप लोगों को, आपको problem solve करना है. Okay, so this is in general, irrespective of any medium. Okay, so this can be later on reduced to a particular case, maybe a free space or a good dielectric or maybe a perfect dielectric. This alpha and beta, or maybe for conductors, alpha and beta can be reduced. So these are the generalized equation of alpha and beta, and this is generalized expression for gamma. So one should again remember this expression of gamma, alpha and beta. So this is in general. Okay, so if you remember the general expression, okay, then a particular case can be reduced to. So अगर मुझे express करना है in terms of free space, so you know in free space sigma is 0. So यहाँ पे 0 substitute करो. Okay, you know in free space mu is mu 0 and epsilon is epsilon 0. तो यहाँ पे वो डाल सकते हो. If sigma is 0, then this becomes 0. ये 0 हो गया. 1 minus 1 is 0. So what will be the sigma? What will be the this value will be 0. So attenuation is 0. That's what we said. Na free space में attenuation is 0. Attenuation होता ही नहीं है because free space में charges नहीं होते हैं. So if you remember this generalized equation, then you can get the alpha, beta, and gamma in any particular medium. Okay, this slide will be shared. This PPT will be shared in the Google Classroom so that you can note down all the expressions. Okay. Okay. अभी आगे क्या करना है हमें? Time should I give a break? Okay. So Shastri sir, should I give a break or इसके बाद ले लो?
ब्रेक दे सकते हो, बाद में इनका ये भी है ना FA.
Are we going to take FA?
ले सकते हैं मगर मतलब अपना क्वेश्चन तो रेडी है.
So students, we will take a break of 10 minutes. and we will again start at 1 o'clock. Okay. Thank you.
Recording stopped.
फर्स्ट टू फोर्थ तक अभी हर सब्जेक्ट का एक एक दिन लेक्चर के बाद तुम लोग ये नहीं लेते हो क्या? तुम यू डोंट लुक इनटू योर एकेडमिक कैलेंडर? एकेडमिक कैलेंडर में FA2 ये वीक में है सभी। ठीक है, नेक्स्ट अदरवाइज नो प्रॉब्लम, हम लोग आज के ठीक है। बट रिमेम्बर नेक्स्ट वीक से होगा मंडे से। हाँ, तो मंडे जो भी लेक्चर रहेगा, शास्त्री सर आर यू देयर? शास्त्री सर, स्टूडेंट्स प्लीज रिमेम्बर दैट नेक्स्ट वीक से तुम्हारा FA2 है। ओके, सो अपना EME का जो FA2 है तो आज नहीं लेंगे, आज सब लोग को दे आर नॉट कंफर्टेबल विथ FA टुडे। सो हमारा जो FA रहेगा वो नेक्स्ट फ्राइडे रहेगा। सो यू कैन रेफर टू दी tutorials so and the chapters which you have covered. Okay, so similar questions will be asked in the FA. Okay, so now we will go ahead with with our chapter. So we have done up till now this that from the wave equation, which is a wave equation which we call it as Helmholtz equation. We understood the three terms, which is gamma, alpha, and beta. So gamma is propagation constant, has some real and imaginary terms. Real term is called as attenuation constant, and the imaginary term is called as beta, which is a phase constant. Now, in this wave equation, this is a wave equation in which we are expressing the wave in terms of the electric field, which is time varying. So now we are going to understand, or we are going to imagine how this electric field is going to be. Okay, so for that we need to do the solution of this wave equation. So if you understand the solution of this wave equation, the constant. So the nature of electric field can be imagined. So as I said, we are studying something which we are not able to see. Okay, so through mathematics only we are going to study the field. Okay, so now we are going to do the solution. Okay, so solution of wave equation. So when you do the solution of wave equation, we always start with the nature of the electric field, which is very much simple. Okay, so the first solution of wave equation can be this. Okay, so now we are imagining how this electric field is going to be. What is going to be the form of electric field? So the first form is very simple. Okay, so start with simple and then go to the complex. That is how the approach is going to be. So पहला फॉर्म क्या कि इलेक्ट्रिक फील्ड कैसा होगा? ये इलेक्ट्रिक फील्ड टाइम वेरिंग तो है. So our earlier static first three chapters इसमें क्या था? This electric field was varying with respect to the spatial coordinates. So this electric field was varying with respect to x, y, z, or maybe it was varying with r, phi, and z. It was varying, but with respect to time, it was constant. So therefore, we call it as a static. But now what is happening? The time varying electric field is not only a variation of x, y, z, but it is also a variation of t. Okay. So therefore, this electric field is time varying, we know, but let's assume that with respect to spatial coordinates, it is constant. So my wave equation is going to be like this. Okay, so why this is zero? Because this is del. Del is dabba by dabba x, dabba by dabba y, dabba by dabba z. Okay, obviously it is a second order, but it is the left hand side shows the differentiation with respect to the spatial coordinates. But what we are saying that it is constant in the space. So that means this del square 0 is going to be del square E is going to be 0. ये इलेक्ट्रिक फील्ड ये फॉर्म में हो सकता है क्या? दिस कैनॉट एग्जिस्ट. व्हाई दिस कैनॉट एग्जिस्ट? सो कैसा है कि हम लोग ही सॉल्यूशन फाइंड आउट कर रहे हैं एंड देन वी आर सीइंग गोइंग बैक एंड सीइंग whether this solution is satisfying all the earlier mathematical equations. So as I was telling my in the tutorials that whenever we are writing any new equation, that new equation must satisfy the previous equations. So therefore, if we think that this electric field is of this form, okay, then it must satisfy our Helmholtz equation. So what was our Helmholtz equation? This was my Helmholtz equation. So what we are saying, del square E is going to be 0. Now this cannot be 0. This cannot be 0 because यहाँ पे क्या है? Right hand side में यहाँ पे gamma है, and gamma is having mu, sigma, epsilon. So gamma cannot be 0 because these are the characteristics of a medium. Okay, so medium के values 0 हो नहीं सकते. Therefore, we say that this form cannot exist because if this has to exist, there has to be some right hand side. That means ये जो electric field है, it is time varying, but it is not constant in space. मतलब ये space में भी vary हो रहा है और time में भी vary हो रहा है. That is what is the meaning of this particular form. So ये form नहीं exist हो सकता. So we are cancelling this form. Now we go to the second form. Second form क्या मैं बोल रही हूँ यहाँ पे? That this is electric field is time varying. लेकिन in the spatial coordinates, how it is going to vary? That this electric field is in terms of x, which is time varying, and it is constant in a perpendicular plane yz. So you know yz plane, this is x, y, z. This is z, this is x, and this is y. So we assume that this electric field is varying with respect to time and it is constant in the yz plane. Okay, so this electric field is moving So electric field का जो expression रहेगा ना, it is going to be a function of x. So it may be 2 sin x. Okay, so जैसे ये electric field move करेगा in the yz plane, so you can imagine that there are these yz planes. This is one yz plane. This is x-axis, huh? This is another yz plane. So this is yz plane. Let's say x is equal to 0. This is yz plane, which is say x is equal to 1. So if you consider this is x-axis, this is origin. This is 1, 2, 3, 4. So these yz planes are crossing. These are yz planes. मैं अगर आप यहाँ से देखोगे तो आपको सिर्फ ये लाइन दिखाई पड़ेगी. So what I am writing यहाँ पे जो मैं लाइन ड्रॉ कर रही हूँ, these are the yz planes which are cutting x-axis at 1, 2, 3, 4. So this is and this is 0. This is your origin. This is also one yz plane. So ये yz plane कौन सा, x is equal to 0. ये yz plane है x is equal to 1. yz plane is x is equal to constant plane. This is x is equal to 2. This is x is equal to 3. So जैसे तुम्हारा EM wave यहाँ पे जाएगा ना, उसका कुछ मैग्नीट्यूड होगा इस पर्टिकुलर प्लेन पे. It will display some magnitude. Okay, ऐसा वो ऑसिलेट होगा ना इलेक्ट्रिक फील्ड. So in the second form it says that this is time varying field and it is constant in the perpendicular plane yz. So ये yz plane जो है उस प्लेन में इसका वैल्यू कांस्टेंट होगा. यहाँ पे हम लोग क्या बोल रहे हैं, इन एवरी प्लेन इट इज कांस्टेंट एंड हियर वी आर सेइंग दैट इट इज इसका वैल्यू कांस्टेंट होगा ओनली इन द प्लेन व्हिच इज yz. So we say that this electric field is a function of only x. Okay, that's what we are saying. Okay, so this is also one of the form. Again, this form they have discarded and they have come to a new form, which is a third form. So how do we express this electric field? This electric field is expressed like this. Okay, as you can see here, x, y, z, t. This electric field is varying with respect to x, y, z and time also. So you know ना कैसे लिखते हैं हम लोग, I is going to be Im sin omega t. This is how you write down any alternating quantity. So what is Im? The maximum value of I. So this is the maximum value of I, which is in terms of x. Okay, so if x is equal to 0, the maximum value is 0. Okay, so ये x is equal to 0 जो प्लेन रहेगा, ये xz प्लेन, यहाँ पे इसका वैल्यू 0 रहेगा. Then another plane is x is, so it will increase. Okay, so the magnitude of EM wave in particular plane is going to be varying with respect to x. J omega t basically is sin omega t. We are writing the exponential term, and this is in direction of x. So इसलिए यहाँ पे a bar x लिया है. This is how you write down the electric field which is time varying. It is showing the phase. फेज का जो है मतलब कि जैसे ये EM वेव मूव होता है ना, ओके, सो फेज शिफ्ट कितना हो रहा है उसका, बिकॉज दिस इज इन एक्स डायरेक्शन ना, तो हर एक प्लेन में उसका कुछ फेज है ना. तो सपोज इट इज सपोज टू ट्रेवल ओनली 45 डिग्री, तो यहाँ पे भी 45 डिग्री, सब जगह फेज डिफरेंस शुड बी सेम. तो डिले हो सकता है ना, तो कितना डिले हो रहा है वो, व्हेन इट इज प्रोपोगेटिंग, हाउ मच डिले इट इज हैपनिंग. अगर फेज शिफ्ट 0 है, phi is equal to 0 है, दैट मींस अगर यहाँ पे वो 45 डिग्री लैगिंग है, तो सब जगह हर एक प्लेन में 45 डिग्री लैगिंग होना चाहिए. सो अगर यहाँ पे 45 डिग्री है, यहाँ पे अगर 90 डिग्री लैग हो रहा है, तो देयर इज अ फेज शिफ्ट ना. सो ये जो j ओमेगा t है ना, ये आपको फेज शिफ्ट के बारे में, दिस इज बेसिकली j ओमेगा t इज योर phi t इन टर्म्स ऑफ टाइम. जैसे हम लोग प्लॉट करते हैं ना, यहाँ पे आइदर यू प्लॉट टाइम and here you plot voltage, or you can plot same as theta and v. So on x axis we always plot this. Okay, so हाँ पाई बाय 2, पाई बाय 2. ओके, सो तुम्हारा जो बीटा है ना, बीटा, दैट विल रिप्रेजेंट्स द पाई बाय 2 टर्म. तो ये जो हम लोग लिख रहे हैं ना, अल्फा प्लस जे बीटा, अल्फा प्लस जे बीटा, दिस इज अ रेक्टेंगुलर फॉर्म. और अगर मैं यहाँ पे लिखती हूँ गैमा एंगल थीटा, दिस इज अ, इसका मैग्नीट्यूड इज गैमा, तो दिस इज अ रेक्टेंगुलर फॉर्म. दिस इज अ रेक्टेंगुलर फॉर्म एंड दिस इज पोलर फॉर्म. So rectangular form gives you the magnitude of this gamma in terms of its x and y coordinate, whereas polar form gives the magnitude and the phase. Okay, so ये जो एंगल है ना, ये एंगल आपको फेज देता है. तो ये एंगल को यहाँ पे इंस्टेड ऑफ e रेज टू j ओमेगा t, हम लोग कैसा लिखते हैं, साइन थीटा प्लस j cos थीटा ना. साइन इसका भी इमेजिनरी और ये रहता है ना, सो हम लोग सिर्फ साइन लेते हैं, इमेजिनरी टर्म हम लोग कंसीडर नहीं करते, या फिर वाइस वर्सा. ओके, सो दिस, yes, 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 this is only just a representation. Okay, so this is how you represent the second form. Again, second form is not possible, so we go to the third form. Okay, in third form what they are saying that this is a this electric field is going to be in the it is in terms of x, it is moving in terms of in along the x direction, it is in direction of x, it is time varying and it is constant in the plane containing xy. Okay, so that means it is a function of z. So तुम्हारा जो e रहेगा, that will be now, that will be a function of z, so it will have z value, not x. Okay, so this third form, okay, is the form which we have accepted as the time varying electric field का form ऐसा होने वाला है. So this is how we are going to write this electric field. So E is going to be the spatial coordinates x y z से vary होगा, t से vary होगा, and I write this expression as z0 as a function of e0 as a function of z, j omega t a bar x. So this electric field will be in the direction of a bar x and it is a function of z. This is a function of z. This particular form is accepted as a nature of time varying electric field. Okay, and what is this particular form is called as, it is called as, so this form, ये form जो पहले मैंने दिखाया था, it is in terms of mathematical expression. Now let's express this form in the words. So what this is form? This form says that the field is having same magnitude in the plane containing the field vector and it has a motion perpendicular to the plane. Okay, so we are talking about the wave motion which is perpendicular to the plane and उसका जो magnitude रहेगा, that will be constant in the field which is containing that field vector. So third form is called as uniform plane wave. Okay, uniform because it is constant. Okay, so it is, as I said, यहाँ पे उसका जो magnitude है, it is constant in the plane containing the field vector. Therefore, it is called as uniform plane. So uniform plane is an electromagnetic wave in which electric field, magnetic field, and direction are orthogonal. That means 90 degrees. And their amplitudes and phases are constant over the planes perpendicular to direction of propagation. So direction of propagation कौन से direction में है? Electric field in the x direction. This is a z. This is the direction of wave, z. This is the direction of wave. So इसमें perpendicular plane कौन सा रहेगा? XY plane. These are all XY planes which are perpendicular to Z. Z axis को कौन सा plane perpendicular रहेगा? Z is equal to constant. I hope it is now clear. Z is equal to constant. Z is equal to constant is XY plane. जहाँ पे x और y वेरी रहेंगे, z का वैल्यू कांस्टेंट रहेगा. ओके, सो दिस इज वन ऑफ द xy प्लेन, दिस इज वन ऑफ द xy प्लेन, दिस इज वन ऑफ द xy प्लेन. इसमें से जो इलेक्ट्रिक फील्ड रहेगा, दैट इज मूविंग इन द x डायरेक्शन. सो इफ दिस इज z, this is going to be y, this is going to be x. So electric field will be moving like this. Okay, and magnetic field will be moving along the y direction. And this entire propagation is moving in the z direction. This particular wave is called as uniform plane wave, in which इसका दिखाती हूँ मैं, मेरे पास एक उसका एनिमेशन. So uniform plane wave का मतलब क्या है? The wave is propagating in the direction normally z. Electric field and magnetic field and the propagation, electric field in the x direction, magnetic field in the y direction. So all the three components are mutually orthogonal, that means they are mutually perpendicular to each other, and their magnitudes, electric field जो रहेगा उसका magnitude और phase, they are constant over the planes perpendicular to the propagation. का मैग्नीट्यूड इस पर्टिकुलर प्लेन में कांस्टेंट होगा, यहाँ पे कांस्टेंट होगा, यहाँ पे कांस्टेंट होगा, यहाँ पे कांस्टेंट होगा. सिमिलरली मैग्नेटिक फील्ड का भी यहाँ पे कांस्टेंट मैग्नीट्यूड होगा. सो एवरी टाइम दिस एनवेलप क्रॉसेस द प्लेन्स, उसका मैग्नीट्यूड विल बी एंड फेज विल बी कांस्टेंट. That is why it is called as uniform plane wave. Again, this is very much ideal kind of plane wave, only for study purpose. Okay, but we are going to understand the plane wave later. This is a part of 5th chapter. So we start with the hypothetical term कि ये जो प्लेन, ये जो वेव है, इसका इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड का मैग्नीट्यूड एंड फेज विल बी कांस्टेंट इन अ प्लेन परपेंडिकुलर टू द डायरेक्शन ऑफ वेव. दैट मींस इसका जो मैग्नीट्यूड रहेगा व्हिच इज कांस्टेंट इन द xy प्लेन.
Sorry to interrupt, please. Hello, miss. Hello, miss. Miss, roll number 28A.
Yes, I'm admitting all the students. Okay, so this is a very ideal or a theoretical kind of wave. So we are studying. Please mute yourself. So we are studying a wave which we cannot see, so we have to start with the ideal form of it. So ideal form of plane wave is called as uniform plane wave. Why it is called as uniform? Because the magnitude and the phases are constant. Where it is constant? It is constant in a plane which is perpendicular to the direction of propagation. So if direction of propagation is z, then the perpendicular planes will be xy plane. So xy plane में electric field or magnetic amplitudes and phases will be constant. So this will be one of the form of the wave which is very much theoretical. So in this particular A part, we are starting with the theoretical concept form of a wave, which is ideally not possible. And in the B part, we are going to understand what is called as only plane wave. So plane wave में this is not constant. Plane wave में which is a practical wave, क्योंकि हम लोग उसको देख नहीं पाते हैं तो कैसे समझेगा? तो यूनिफॉर्म तो होने वाला नहीं है, that is very much sure, because there are lots of losses which takes place. So इसलिए इसका amplitude और phases, there are so many obstacles. There are droplets, there are water vapors in the free space when the EM wave travels. So उसका phase shift भी होने वाला है. Okay? हाँ, so this is a very theoretical wave कि उसका amplitude और phases constant है. So considering the ideal value, okay, ideal or the ideal concept, we will again further study this wave. Okay, and then this, once you understand, then we apply that understanding over the practical wave. So practical wave, plane wave. So वहाँ पे हम लोग in the B topic, in the B part of this chapter, we are going to study the concept which is called as reflection, refraction, जो actual में होता है. So whenever EM wave strikes on any of this plane, there is going to be a reflection also. अभी हम लोग reflection के बारे में बात नहीं कर रहे. We are talking about a very much ideal, good boy बोलते हैं ना, good boy. वैसा we are talking about a very good plane, a very good wave. ओके, जिसमें कुछ भी खामियां नहीं है, ओके, लेकिन नो बॉय और नो गर्ल इज वेरी मच गुड. We are a package having some positive points and negative points. Similarly, wave का भी कुछ positive और negative का जो part है, that we are going to consider later. So this was our good wave, ideal wave, which is called as uniform plane wave. Okay. So now we are going to make changes in the wave equation. So this is our wave equation, solution of wave equation. So this is solution of wave equation because we derived the wave equation in terms of electric field. Therefore, उसका solution है electric field. This is my time varying electric field, which we have fixed, which I have fixed up now. So this is very क्या बोलते हैं, आपको थोड़ा फर्स्ट टाइम सुनने के लिए you may find it this is time varying electric field. Okay, जो टाइम वेरिंग है इसलिए उसका यहाँ पे विथ रिस्पेक्ट टू टाइम वेरिएशन यहाँ पे दिख रहा है, एंड इट इज ऑल्सो वेरिंग विथ रिस्पेक्ट टू XYZ और स्पेशल कोऑर्डिनेट्स, इसलिए यहाँ पे Z लिखा है. ओके, सो दिस इज अ टाइम वेरिंग फील्ड विच वी हैव एक्सेप्टेड. नाउ लेट्स गो. अभी ये जो चेंजेस है ना, ये मैंने वेव इक्वेशन में डाला है. सो पहले वाला वेव इक्वेशन क्या था हमारा? पहले वाला वेव इक्वेशन हमने लिखा था ऐसा. व्हाट वाज आवर वेव इक्वेशन? डेल स्क्वायर E is equal to gamma square E. This was our wave equation earlier. This was gamma. Why नहीं है gamma? But now we know that this electric field is in the x direction and it is in the it is a function of Z. इसलिए मैंने ये EX as a function of Z लिखा है. यहाँ पे भी जहाँ पे E है वहाँ पे EX as a function of Z. Okay, so this was our earlier case जहाँ पे मुझे इलेक्ट्रिक फील्ड कैसा होगा, क्या होगा, उसके बारे में कुछ पता नहीं. Now I have fixed up that my electric field is going to be like this. So I have made changes in my wave equation. So this is my Helmholtz wave equation, wherein the specific electric field का जो parameter है that I have mentioned. Okay. So this is my wave equation. So this is del square. This is double order differential equation. So obviously double order differential equation में I am going to have two terms. Okay. So what is this term? This term is called as E0 plus E raised to minus gamma Z. This is E0 minus E raised to gamma plus gamma Z. So what is this? These are the So this particular wave is going to be superposition of two waves. These are two waves. Okay, so ये जो ये जो wave है, Helmholtz wave equation. This wave is a combination of two waves. So whenever we say electric wave, whenever you say that the EM wave is propagating, it is basically a superposition of two waves. Which are they? They are the incident wave and the reflected wave. So at any point, okay, so for E0 plus it represents the electric field amplitude in the positive Z direction. Okay, and this E0 minus represents the electric field is along the minus Z direction. Because see, whenever you say that the as I was talking about, this is Z direction. EM wave ऐसा जा रही है और ये किसी एक plane के through जाएगी. So when it strikes, जैसे आपका electric whenever you get your mobile ring, so तुम्हारा EM wave जो है वो हर एक medium से हर एक plane को strike करके फिर तुम्हारे mobile तक आता है वो wave. Okay, so whenever it strikes any plane, maybe it's striking some plane which is your building ka face, so it's going to be reflected. So in free space there is a reflected wave and there is a incident wave. So this is a incident wave which is along the Z direction. Positive Z direction में जो आती है, that is your incident wave which get incident in this plane, which gets incident on this plane. And since it strikes on this plane, some part of it gets reflected. that is called as this is an incident traveling along the minus z direction. So इसलिए यहाँ पे माइनस लिखा है. Okay, so we say that the EM wave is comprised of two waves. Okay, अभी आगे क्या दिया है देखो, this gamma is alpha plus j beta. Okay, ये गामा की जगह मैंने अल्फा प्लस जे बीटा लिखा है. मैं रिफ्लेक्टेड वेव के बारे में कुछ नहीं बोलने वाली हूँ. We will add them later. Like right now, just understand what is the incident wave. So this is an incident wave in terms of, I am expressing this wave in terms of its electric field. Okay, so इसलिए सिर्फ ये z क्यों लिखा है मैंने, because my electric field is only a function of z coordinate. Okay, so this is z because you know that electric field is a function of z and it is a function of t. E0 plus indicates it is a incident wave. ये जो gamma है, ये gamma के जगह मैंने अल्फा प्लस जे बीटा लिखा है. So अभी तक मैं ये कंसीडर नहीं कर रही हूँ. I am considering only the incident part of it. Okay, j ओमेगा. Okay, ओमेगा ये जो j पार्ट है ना, ये j बीटा z और ये j ओमेगा, इसको कंबाइन किया यहाँ पे, और जो रियल पार्ट है उसको बाजू में दिया है. Okay, so e raised to minus alpha z is taken here and e raised to minus j beta z and j omega t is combined here. So j कॉमन है दोनों में, इसलिए j बाहर निकाला है. So here you have e, imaginary. So because that represents your phase. So यहाँ पे देखो, if I e raised to minus alpha z, अगर ये ब्रैकेट को खोलूंगी तो, और e raised to minus j beta z. So e raised to minus j beta z और e raised to j omega t, इनको कंबाइन करके यहाँ पे लिखा है. And this term is written here. Okay, and this is a bar x. So what I am writing is the electric field expression. This is electric field which is time varying, and also this is electric field of incident wave. Okay, अभी तक मैं सिर्फ incident wave के बारे में लिख रही हूँ. Okay, ठीक है. So this is a real part. रियल पार्ट लिखा है. This is a real part because ये real part है ना, ये imaginary part है. Reflected wave, it is imaginary. This is the incident wave which is a real part of it. Okay, so E z comma t is this. Okay, इसका real part ये है. E raised to j omega t is cos plus j sin. ये आपको शायद पता है ना. As I was talking to e raised to j theta, e raised to j omega t or j theta, e raised to j omega t is
Recording in progress.
is equal to cos omega t plus j sin omega t. So I am considering only the real part. Okay, that is cos. इसलिए ये जो j omega t है ना, ये एक पार्ट, ये पार्ट जो है ना, इस पार्ट को मैंने एक्सपांड किया है ऐसा, और इसका जो रियल पार्ट है दैट इज रिटन, नॉट द इमेजिनरी पार्ट. स्टडी पर्पस के लिए इमेजिनरी नहीं लिखते हैं, सिर्फ कॉस कंपोनेंट ही लिखते हैं. सो एनी साइनसॉइडल वेव इज अ कॉम्बिनेशन ऑफ कॉस वेव एंड द साइन वेव बोथ. ओके, सो जो इमेजिनरी पार्ट है ना, जो फूरियर ट्रांसफॉर्म से जो इमेजिनरी आता है, वो हम लोग नहीं करते फॉर स्टडी पर्पस. ओके, सो हम लोग बोलते हैं ना, देयर ऑलवेज अ हार्मोनिक्स. सो वो दैट पार्ट आई एम नॉट कंसिडरिंग. आई एम कंसिडरिंग ओनली द यस. सो दिस, ये जो रियल पार्ट है वो ऐसा ही रखा मैंने. ये जो e raised to j omega t minus part is cos omega t minus beta z. Okay, so this is the electric field of incident wave which I am writing. In the similar way, electric field of reflected wave. So E0 minus represents the electric field amplitude in the negative z direction. Okay, so same जो लिखा है ना, जो मैंने लिखा है, this was for incident wave. ये जो अगर प्लस करती हूँ, because यहाँ पे प्लस है, देखो, this sign is plus. Okay, so यहाँ पे प्लस होगा तो क्या होगा, यहाँ पे भी प्लस होगा. So cos omega t plus beta z will be, okay, that will be my electric field of reflected wave. Okay, so this is my reflected wave. इन दोनों को अगर मैं ऐड करती हूँ, then this is my entire electric field. So this is the electric field, this is my incident wave, and this is my reflected wave. And everywhere I have written the real part of it, not the imaginary. इसका जो साइन पार्ट है वो नहीं लिखा है. तो इससे आपको क्या समझ में आता है? इससे आपको समझ में आता है, हाँ, ये है. सो रिफ्लेक्टेड जो इमेज जो इंसिडेंट होता है ना, वहां पे हमेशा ये दिस इज इन पॉजिटिव जेड डायरेक्शन, लेकिन यहाँ पे माइनस साइन आती है. सो यहाँ पे अगर माइनस साइन है, इसका मतलब है माय इंसिडेंट है, और ये प्लस आ गया तो ये माइनस जेड में जाती है. ओके, सो this is similar to your I is equal to Im cos omega t. Im cos omega t plus or minus phi. ऐसा लिखते हैं ना साइनसॉइडल, है ना? So this is a phase difference. So this phase is given by beta. Okay. So अगर z is equal to 0 है तो इसका phase difference होगा 0. अगर z is equal to 1 plane है, because your wave is along the z direction. And ये अलग अलग planes है. This is z is equal to 0 plane. This is z is equal to 1 plane. This is z is equal to 2 plane. This is z direction. So जब भी तुम्हारा EM wave इस plane से गुजरेगा, z is equal to 0, तभी उसका phase होगा 0. यहाँ पे सिर्फ z is equal to 0 डाला है. अगर z is equal to 1 पे जाएगा तो उसका phase difference कितना होगा? बीटा उतना. z is equal to 2 में जाएगा तो 2 बीटा. बीटा इज अ फेज कांस्टेंट. ओके, सो बीटा का वैल्यू कुछ भी हो सकता है. ओके, सो यू हैव टू जस्ट सब्स्टिट्यूट द वैल्यू ऑफ जेड, उतना तुम्हारा फेज डिफरेंस होने वाला है एज योर EM वेव प्रोपोगेट्स. ओके, एंड दैट इज बिकॉज ऑफ द लॉसेस एंड द डिस्टर्बेंस व्हिच यू गेट इन द फ्री स्पेस. और ये क्या दिखाता है? ये तुम्हें दिखाता है अटेन्युएशन कितना होगा. सो z इज इक्वल टू 0 मतलब अटेन्युएशन 0, e रेज़ टू 0 इज 1. ओके, सो इसका मतलब z इज इक्वल टू 0, इस प्लेन से जब भी तुम्हारा EM वेव जाएगा तभी उसका एम्पलीट्यूड कितना होगा? E0 प्लस, क्योंकि E0 प्लस इंटू 1 होगा ना, ये e रेज़ टू माइनस 0 होगा, ये माइनस 0 इज 1. सो इसका मैग्नीट्यूड कितना होगा? यहाँ पे होगा E0 प्लस, इतना मैग्नीट्यूड होगा. जैसे ये z इज इक्वल टू 1 पे जाएगा EM वेव, तो ये क्या होगा? e रेज़ टू माइनस अल्फा. सो टोटल एम्पलीट्यूड कितना होगा? e रेज़ टू E0 प्लस इंटू e रेज़ टू माइनस अल्फा. तो अल्फा का वैल्यू सपोज 1 है तो e रेज़ टू माइनस 1 होगा. इसका मतलब इसका वैल्यू कम होगा ना इससे, बिकॉज यू आर मल्टीप्लाइंग विद सम e रेज़ टू माइनस 1. सो जैसे जैसे ये वेव प्रोपोगेट होगा, इसका वैल्यू, दिस वैल्यू विल बी लेस देन e रेज़ टू 0 प्लस. जैसे आगे जाएगा इससे भी कम होगा. So that shows that it is getting attenuated, and that is because of the disturbance or the charges which are present in the medium. So this particular expression tells you that this is a EM wave whose, okay, I hope it is clear that how to interpret this equation, and this field is a harmonically time varying field. तो ये जो तुम्हारा वेव रहेगा ये साइनसॉइडल रहेगा और कॉस वेरिएशन रहेगा, कोसाइन वेरिएशन, इसलिए कॉस लिया है हमने. ओके, सो दिस इज लिटिल बिट डिफिकल्ट टू अंडरस्टैंड, बट इफ यू इमेजिन, ओके, देन it is little bit of understanding if you are hearing for the first time. So let us see this equation. So this is my incident wave equation. So in my last tutorial, I was talking to students and मैंने उनको ऐसा ही कुछ इक्वेशन दिखाया था. ओके, सो अगर मेरे पास ये इक्वेशन आता है तो इससे मुझे क्या क्या इंफॉर्मेशन मिलता है? मुझे इंफॉर्मेशन मिलता है दैट ये जो इलेक्ट्रिक फील्ड है, दिस इज अ इंसिडेंट वेव. दिस इज अ इंसिडेंट वेव बिकॉज इट इज ट्रेवलिंग इन विच डायरेक्शन? पॉजिटिव जेड. कैसे मुझे पता चला? ये क्या है? ये z है, मतलब इट इज इन z डायरेक्शन. पॉजिटिव या निगेटिव डिपेंड्स ऑन दिस साइन. अगर ये साइन निगेटिव है तो माय इलेक्ट्रिक फील्ड और माय वेव इज ट्रैवलिंग इन द पॉजिटिव z डायरेक्शन. ओके, प्लीज अंडरस्टैंड ना, इसमें आपको क्विजेस पूछ सकते हैं हम लोग. आई कैन गिव यू एनी एक्सप्रेशन एंड आई कैन आस्क यू ये वेव इक्वेशन कौन से डायरेक्शन में जा रहा है. तो सब लोग क्या देखेंगे? ये a बार x दिखेंगे और मुझे आंसर देंगे दिस इज इन x डायरेक्शन. बट वेव का डायरेक्शन यहां से पता चलता है. तो ये क्या है? दिस इज द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. ओके, सो वी आर एक्सप्रेसिंग दिस इलेक्ट्रिक फील्ड, वी आर एक्सप्रेसिंग दिस वेव एज इन टर्म्स ऑफ इट्स इलेक्ट्रिक फील्ड. बिकॉज व्हेन आई से ये वेव, उसका कॉन्स्टिट्यूएंट्स क्या होने वाले हैं? इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड. तो आप ईएम वेव का इक्वेशन इलेक्ट्रिक फील्ड के टर्म्स में भी लिख सकते हो, मैग्नेटिक फील्ड के टर्म्स में भी लिख सकते हो. So what I'm writing here is, so here I'm writing EM wave का equation which is a incident wave. हाँ, मैंने अभी reflected wave के बारे में कुछ नहीं लिखा है. This is a incident wave in terms of electric field. So वो electric field जो है इसका direction ये दिखाता है. This is a electric field का direction which is in the x direction. तो EM wave का propagation कौन से direction में वो कैसा पता चलेगा आपको? यहाँ से. यहाँ पे क्या है? x है, y है या z है? अगर यहाँ पे y है, दैट मीन्स माय प्रोपोगेशन इज हैपनिंग इन y डायरेक्शन. यहाँ पे अभी z है, इसका मतलब द प्रोपोगेशन इज हैपनिंग इन द z डायरेक्शन. पॉजिटिव z है कि निगेटिव z है पता चलेगा ये साइन से. अगर ये साइन निगेटिव है तो प्रोपोगेशन इज इन द पॉजिटिव z डायरेक्शन. ठीक है, ये पता चलेगा. यहाँ पे क्या पता चलेगा मुझे? अटेन्युएशन. एट दैट पॉइंट इज लाइंग इन अ प्लेन. Okay, so z is equal to 1, z is equal to plane, z is equal to 2, 4, 5, 6. These are the planes. So ये जो प्लेन रहेगा ना, उस तो वेव जो है वो एक पॉइंट से पास होगी ना. वेव जो है वो इस पॉइंट से पास होगी. सो इसका जो भी z कोऑर्डिनेट रहेगा, ओके, सो उस पॉइंट पे कितना अटेन्युएट हो रहा है वेव, दैट इज रिप्रेजेंटेड बाय दिस टर्म. एंड दिस इज इट्स एम्पलीट्यूड एज z is equal to 0. सो शुरुआत का कौन सा प्लेन होगा? z is equal to 0, जहां पे अटेन्युएशन 0 होगा. उसके बाद अटेन्युएशन चालू होगा. z is equal to 1, z is equal to 2. यहाँ पे तुम्हारा एक्चुअल में अटेन्युएशन वेव का चालू होगा. दिस इज z is equal to 2. सो E0 प्लस इंडिकेट्स z is equal to 2 में उसका एम्पलीट्यूड कितना है. सो दिस इज द एम्पलीट्यूड at this particular point, and this point lies in z is equal to 0. Okay, so suppose wave ऐसा है 2 e raised to minus 3 z cos ओमेगा के जगह मैं लिखती हूँ लगे से 1000 t minus 5 z. ओके, सो इसका मतलब क्या है? 2 मैग्नीट्यूड कभी है? व्हेन इट इज स्टार्टिंग, जब वेव स्टार्ट हो रहा है. दिस इज अ स्टार्टिंग, मतलब तुम्हारा जो एंटीना है, सपोज दिस इज योर एंटीना, एंटीना से ईएम वेव चालू हो रहा है. ओके, सो यहाँ पे उसका मैग्नीट्यूड कितना है? E0 प्लस. जैसे जैसे ये एंटीना को ईएम वेव छोड़ेगा और आगे आगे जाएगा, तभी ये सब प्लेन्स आएंगे ना, इमेजिनरी प्लेन्स विल बी देयर. ओके, so this plane जहां पे एंटीना है वहां पे it is z is equal to 0, then it is 1, then it is 2, then it is 3. so जैसे जैसे ये प्रोपोगेट होगा वैसे वैसे उसका अटेन्युएशन धीरे धीरे होगा. ओके, सो z is equal to 0 रहेगा तो that is this plane. z is equal to 1 रहेगा तो 2 into e raised to minus 3 उतना उसका एम्पलीट्यूड रहेगा. z is equal to 2 होगा तो it is minus 6. तो जैसे जैसे ये बढ़ते जाएगा वैसे वैसे यू आर मल्टीप्लाइंग, यू आर रिड्यूसिंग द एम्पलीट्यूड. ओके, So this is how you can interpret the yes yes. तो ये टाइम वेरिएशन बताता है कि एट डिफरेंट टाइम कितना वैल्यू होगा उसका, एंड दिस रिप्रेजेंट्स एट स्पेशल कोऑर्डिनेट्स कितना वैल्यू होगा, बिकॉज योर वेव इज डिपेंडिंग ऑन XYZ also and T also. So we have assumed here the third form, इसलिए यहाँ पे Z है. So your electric field, हाँ हाँ. So ऐसा कुछ नहीं है. This is globally एक standard follow करते हैं ना, वैसा हम लोग standard follow कर रहे हैं कि wave is propagating in Z direction. So any book you take ना, you will have this standard notation of EM wave, which is the wave is propagating in X in the Z direction, electric field in X and magnetic field in Y. This is just a standard way of. Otherwise, हर एक बुक में अलग अलग होगा तो हर एक बुक में अलग अलग इक्वेशन रहेंगे and we will all be confused. So इसलिए एक standard notation वो use करते हैं, that's it, only for our understanding. Okay, so okay, so I think this is where we can stop here. So अभी हमने ये लिखा है EM wave का equation in terms of electric field. Now in the next lecture we will develop the EM wave का equation in terms of magnetic field. Okay, so that is our next slides. So उसके लिए हम लोग ये Maxwell's equation use करेंगे and we will. Okay, so अभी इसमें how equations, तो पहली बात तो आपको ये equations का ये जो मैंने अलग अलग बताया ना, ये पता होना चाहिए. तो इसके ऊपर हम लोग क्विज डाल सकते हैं, क्विज इक्वेशंस. ओके, जो प्रॉब्लम सॉल्व करेंगे ना, प्रॉब्लम में भी अभी इसमें जो ओमेगा है, जो बीटा है, उसको उसकी जगह वैल्यू आएगा. तो यू शुड बी फैमिलियर टू दिस इक्वेशन. तो अल्फा क्या है, इसका वैल्यू अगर 3 है तो वी कैन आस्क यू सम क्वेश्चन, कितना एटेन्यूएशन हो रहा है. सो यू शुड नो कि इस इक्वेशन से मुझे क्या इंफॉर्मेशन एक्सट्रैक्ट करना है. सो दिस इक्वेशन इज, दिस स्लाइड इज वेरी इंपॉर्टेंट. ओके, टू सॉल्व द प्रॉब्लम्स. तो इसके ऊपर जो प्रॉब्लम्स है ना, वो हम लोग अभी ट्यूटोरियल में लेंगे. सो इन द लेक्चर्स वी विल जस्ट अंडरस्टैंड द कंसेप्ट बिहाइंड ऑल द मैथमेटिक्स, बिकॉज नाउ वी हैव टुडेज लेक्चर और नेक्स्ट लेक्चर मिलेगा हमें. ओके, उसके बाद लेक्चर में शायद छुट्टी है कुछ तो, and then you have submission, so we may have to arrange one more extra lecture. So we will inform you next week may share extra lecture. So next Friday we will complete this 5th chapter. So next week tutorials में हम लोग इसके numericals लेंगे. Okay, so numerical miss मत करना. Okay, so we will solve numericals and I will give you similar numericals to solve at home. Okay, because as I said earlier, students please remember, पहला 3 चैप्टर में न्यूमेरिकल्स कम है, थ्योरी ज्यादा है, और लेटर 4 चैप्टर्स 4, 5, 6 लेटर 3 चैप्टर्स में न्यूमेरिकल्स कॉम्प्लिकेटेड है और कंसेप्ट ज्यादा है. एंड 4, 5, 6 चैप्टर्स is very important because it connects you to your further chapters which is in antenna. फर्दर सब्जेक्ट को कनेक्ट करता है ये 3 चैप्टर्स. ओके, तो इसलिए एंटीना समझने के लिए आपको ये सब समझना जरूरी है. ओके, और इसके प्रॉब्लम्स गेट में बहुत पूछते हैं. सो अगर आप गेट देने वाले हो तो 4, 5, 6 चैप्टर्स आपके लिए बहुत इंपॉर्टेंट है. इसलिए इस चैप्टर के लेक्चर्स एज वेल एज ट्यूटोरियल्स मत मिस करो. ओके, सो नेक्स्ट वीक we will complete and we will have maybe 1 or 2 extra lectures. So thank you very much. I stop share. Students, if you have the